can be made to coincide throughout. Plane figures with the same size and shape, and therefore can be made to coincide throughout. Congruent figures which have the same size and shape and therefore can be made to coincide throughout. Do these figures have the same size and shape, class? No. Is it even remotely possible that they could coincide throughout? No. They don't have the same size and shape. Those cannot be congruent. Do these two figures have the same size? No. Do they have the same shape?
Yes.
They appear to have the same shape, but they're not the same size, correct? What about these two figures? Maybe not perfect, but approximately, right? The best, freehanding it. They appear to have the same size and shape. Now, to know if they could coincide throughout, one way to do it would be to get a saw and cut this part of the chalkboard out and place it on top of the other one, and that would show whether or not they coincide throughout. But I'm not going to do that. What would be interesting here, though, is the reason they have the same shape is because this angle and this angle are the exact same size, or should be, if they really were perfectly congruent. These two angles would be the same size. These two angles would be the same size, agreed? If they coincide throughout, then these angles would fit perfectly on top of each other, and that's actually the definition of equal angles, right? Angles whose sides can be made to coincide. But these angles are the same. These angles are the same. These angles are the same. But why don't these two triangles coincide throughout? Why aren't they congruent?
Because they're not equilateral.
Well, these aren't equilateral either.
Equiangular.
They're equiangular. These are three different sizes of angles.
They don't have the same size.
There we go. This length of this side isn't even close to the same as this one, right? And this isn't the same size as that one. So not only must the angles be equal, but these two sides better be the same, and these two sides better be the same, and these two sides had better be the same. But if all three angles and all three sides here match all three angles and all three sides here, then they would perfectly coincide. Same size, the sides are all the same, and shape, the angles are all the same. Angles give shape, sides give size. Does that make sense? The matching parts then, this angle, if I call this triangle A, B, C, and I call this one X, Y, Q, then we could say that angle A and angle X match each other, right? Angle B and angle Y, side X, BC and YQ, right? They match each other. These matching parts are called corresponding parts. Corresponding, your shorthand is corresp, and we're just too lazy to write onding. Corresponding parts. Definition, the matching equal parts of congruent figures. The matching equal parts of congruent figures, corresponding parts. The matching equal parts of congruent figures are called corresponding parts. They're also called homologous parts. Most textbooks don't use that term, but if you were to see that, homologous. What are the homologous parts? Matching parts, corresponding parts. We use the term corresponding in this class. These would be the corresponding parts to each other. Now, it's easy to see when the figures are arranged the same way. It might be a little bit harder if we had, and this is going to be harder to draw as well, but if we had something like this here. Well, these figures, if these two lines are equal, and 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 this angle matches that angle, and these angles match each other, and these angles match each other, and these angles match each other, then they would also be congruent figures, right? We've got these corresponding parts of these figures as well. Now, I do want to give you a quick note here on this idea of congruence versus equality. Congruence, remember, is same size and shape. Does a line have shape? No. All lines exactly the same shape anyway, right? The only thing that makes a line different is how long or short it is, right? which is why we refer to line segments as being equal, because they have the same size. There really is no shape to them, correct? So that's why we don't refer to lines as being congruent. We refer to line segments as being equal. Angles, do they have shape? Yes, but their shape is determined by their size, right? The shape of an angle, acute, obtuse, reflex, is determined by actually technically the size of that angle, correct? So there again, technically, although we would think, looking at it, yeah, an angle has shape. No, an angle has size. So angles also referred to as being equal if their sides can be made to coincide. Does that make sense? So that's why you have the definition of equal, not congruent line segments. Equal, not congruent angles. But figures, circles, triangles, rectangles, squares, whatever, those are referred to as being congruent. Just want to make that quick note there. Let's consider this polygon here, M-N-O-P, and let's call this thing G-H-I-J. Which angle matches or is corresponding to angle M, Ethan? Which angle is corresponding to angle M? Angle H. Which angle corresponds to angle N? Kendall?
Angle G.
Angle G. Audrey, which angle corresponds to angle O?
J.
Angle J. Chris, which angle corresponds to angle P? I. Now, how are we going to label these? We could say that polygon, when we name a polygon, typically we just go around counterclockwise. So M-N-O-P, really doesn't matter how you label it though. Polygon M-N-O-P, this symbol means is congruent to polygon, but when you state congruence, we need to show the matching pieces based on the letters. So since I started with M, I need to start with its matching letter H. The one that matches N is G. The one that matches O is J, and the one that matches P is I. And so when we label our congruent figures, we're going to make sure the letters line up with the corresponding parts. Does that make sense? So if I had these two triangles, and we call the first one ABC, and we call the other XYZ, I would have to say that triangle ABC is congruent to triangle. What order would the letters have to go in here? Genesis? X, Y, Z, if I were showing a congruence, because the matching parts would have to line up in the lettering. The significance of that is that if you're told that a couple of triangles are similar, you can deduce quite a bit just from the lettering that you're given. For instance, if I were told that triangle ETJ is congruent to triangle I'm looking at botch it here. Is it ANM? R. Arm, okay. ETJ is congruent to arm, okay. We can deduce from this class that angle E must equal angle A. We can deduce that angle J must equal angle M. We can deduce that angle R is equal to angle T. But more than that, we could also conclude, could we not, from this, that AB is equal to XY, right? AB equals XY. I could conclude that CB equals ZY, right? CB, ZY. I could even conclude that AC and XZ are equal. AC, XZ. So, TJ, the line segment, the side of the triangle, must be equal to what other line segment based on the lettering, Kendall? RM. We know that RA must be equal to what other segment, Audrey? TE. We know that JE must be equal to what other segment, Ethan? MA. And And so just from lettering alone, we can tell quite a bit about what parts must be equal. Turn your books to page 29. Turn your textbooks to page 29. And take a look at exercise number 2. I guess one of the points I'm trying to make here is when you describe figures as being congruent, you can't just name them however you want to. It's got to be very carefully done. But number 2, we are told that triangle RST, wherever it is, we aren't given a picture, is congruent to triangle MNP. We're told specifically that RT is equal to MP. We're told that TS is equal to PN. We're also told that angle T is equal to angle P. But there are some other corresponding parts that need to be included here. What other corresponding parts are there? There's 3 more things you could write down. Do this on your paper real quick, or you can do it off to the side of your book or something real likely there. What other pieces, corresponding parts, are present, though they did not give them to us? Write them down. See if you can get all 3. RT and MP are corresponding sides. TS and PN are corresponding sides. T and P are corresponding angles. And it's now in stock at Walmart, even though it wasn't a few months ago. You know I had to go there.
Now it's wipes. Like maybe what?
Yeah. And sanitizing wipes. All right, Chris, let's see if you go 3 for 3. What are the other corresponding parts they didn't give us?
SR equals N.
SR equals
NM.
NM. Okay, perfect. How many have the same other set of sides? Okay, now there's a triangle, right? So 3 sides, we've got 3 sets of corresponding sides. So the other 2 should be sets of angles.
S equals N.
Angle
S
S
equals N, sorry.
Angle S equals angle N, all right.
And then angle R equals N.
Angle R equals angle M. How many got the other missing pieces also? All right, again, we call these matching equal parts, class. Not congruent. Congruent describes the figures. The parts are referred to as being corresponding parts. There we go, corresponding parts. All right, so we got this next picture here with a triangle ABC, and we've got another triangle. And here's a notation that you'll see quite a bit in this class, and especially in pre-calculus when you get to your senior year. A couple of triangles, and because they are congruent to each other, congruent figures, the parts being corresponding, A prime, to show that it's kind of connected, if you will, to the A. It's tied to the A in the sense that it's corresponding. B and B prime, C and C prime. So right off the bat, we can see which angles must be equal if we were to say that triangle ABC is congruent to triangle A prime, B prime, C prime. What are the equal angles, Genesis?
Angle AC equals
Well, AC is a line.
A equals A prime.
Angle A prime.
Angle B equals angle B prime. Angle C equals angle C prime.
Good, really straightforward. What about the sides here, Kendall?
Triangle.
No, sides, like a line segment.
AC.
Okay, AC equals,
A prime. C prime.
good.
BC. B prime. C prime. And AB. A prime. B prime.
There we go. See how easy congruent figures are. Nothing real mind-shaking, mind-blowing here. Not yet, guys. It's like, I know it's coming, I know it's coming. All right, well, we are out of time, so we will come back, finish up this thought tomorrow. We will begin working on some constructions tomorrow. Make sure you have compass and straight edge with you. Make sure you have compass and straight edge with you for tomorrow. All those constructions. Tonight, no written homework, but do study pages 25 to 30. Pages 25 to 30.
That's circle.
Circles and congruent figures. All right, you are dismissed. Have a wonderful rest of your day.
Quiz.